Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, in our today's lesson, we will discuss about the graphical representation of the Boyle's law. As in a previous lesson, we have already learned that what does mean by the Boyle's law as well as the experimental verification of the Boyle's law. So, what is the graphical representation? Before the start of the graphical representation, you guys must know that what was the main relationship given by the Boyle's law. He just gave the relationship between volume and pressure, and he says that volume is inversely proportional to the pressure, and the end of the mathematical form we just gain that product of volume and pressure is a constant value. So this was a simple mathematical form of the Boyle's law, and it has been also proved by an experiment and by the use of simple examples. So when we are going to represent it graphically here, we will take the volume along x-axis and the pressure along y-axis. So here at the start, the volume of the gas is less and the pressure is high. But as the pressure is going down, you can see that the volume of the gas is going to be increase. So here we just gain a curve line when we plot a graph between the relationship of pressure and volume along x-axis and y-axis. So this curve is mainly called as the isotherm. It is called as isotherm, where the isos mean same and the therm mean heat. So this curve is mainly called as isotherm, and all this is going to be take place at the constant temperature. Temperature over there we have it is constant. Next, we can explain it in three different terms when we have the relationship between pressure and volume. So here we have a graph between pressure and volume, where the volume is on x-axis and the pressure is along y-axis. So the main relationship between pressure and volume is the inverse relation, where P into V is constant is equal to K, and V is inversely proportional to the P. It's mean when we increase the pressure, the volume is going down, and when we decrease the pressure, the volume is going up. This can also be done by the help of the graph flotation between pressure and volume. So here we can see that almost the volume of the gas is 10 point something, or we can say that it is almost 13, and the pressure over there we have 120. But on the other hand, as the pressure is going down, at this point you can see that the pressure is almost 45, and the volume we have it is 30. So by the decrease of the pressure, the volume increases from 13 to 30 centimeter cube. At the end, when we reduce the pressure from 120 to almost here 25, then the volume of the gas almost reaches to the 50. So this is the simple relationship between pressure and volume according to the Boyle's law, and it is its graphical representation. Next, if we plot a graph between the pressure and volume at different temperatures. In the first, when we keep the temperature 0 degrees Celsius, we can see that the isotherm is closer to the value. Here, temperature T1 and the pressure and volume relationship by changing the pressure. But when we increase the temperature from T1 to T2 and keeping it constant and changing the pressure, now we are changing the pressure. It will also affect the volume in simple way, and we just gain the second isotherm at the end when the temperature is T3 and we change the pressure, then it also changes the volume, which is denoted by T3. So here what will be the effect of change of temperature, or we just take the effect of pressure on the volume of the gas at different temperatures at T1. So the volume at T3, when temperature increases, then the volume also increases. So the volume at temperature T3 is higher as compared to temperature T2, and the volume at temperature T2 is higher as compared to the temperature T1. So this was a simple relationship when we change the temperature, or we take the effect of pressure on the volume of a gas at three different temperatures with T1, T2 and T3. After that we have a graph in which we will show the relationship or between product of pressure and volume versus pressure. When we take the pressure along x-axis and the product of pressure into volume along y-axis, then we just gain a straight line. Now what does mean by this straight line that we are going to take? So that straight parallel line of product of pressure and volume to the pressure, it indicates that K is a constant quantity. Now K is the proportionality constant of the Boyle's law. When it is a constant quantity, so at higher constant temperature, when we high the temperature and then we keep it as a constant value, then the volume of the gas increases and the value of product of P into V, it should also increase, or it must also remains constant. Now all that depends upon the change of the pressure. When we simply increase or decrease the pressure, in this graph, at the new temperature, we just gain the straight line again that is parallel to the pressure axis along y-axis or x-axis. This type of straight line will help us to understand the behavior of gases by changing the conditions prevailing on them. So this is all about this lecture, that what will be the effect of pressure on the volume and its graphical representation. I hope you guys understand this was a very simple topic, and in the next we will discuss about the experimental verification of the Charles law. For that time, you guys have a good day and Allah Hafiz.